Okay guys, this is the final video for Chapter 7, Lesson 7, and we're going to be going over the last two examples in solving two-step inequalities. Now here we have a inequality that looks like a rational numbers involved, or fraction as you guys like to call it, but you're going to see that these, just like everything else, are solved in the exact same way every other problem has been that we've done so far in this chapter. So let's get right to it, knock this out of the park, and we'll be done just that much faster. So here we go. As always, process is rewrite whatever problem they give you all over again. So in this case, I have x divided by 2 minus 5 is less than negative 8. All right, let me make my little chart that talks about what's happening to my variable x. Well, x is first being divided by 2, and then it is being subtracted by 5. Next thing I do is find those inverse operations. The inverse of dividing is multiplying. The inverse of subtracting is adding. These two steps are how I'm going to solve my inequality here. As always, you want to get rid of your addition or subtraction first. So since I have addition here, I will add 5. I will add it to the number where I got it from, which is this 5 right here. And I will also add it to the answer on the other side of my symbol. Notice I did not touch the x over 2, so it just drops on down. X over 2. Minus 5 plus 5 equals 0, which is nothing, so I'll leave it blank. My symbol, still stays the same. Negative 8 take away 5. If I go to negative 8 on the number line and then go 5 steps in the positive direction, I end up at negative 3. So I've done the first step. My last step now is to go ahead and multiply both sides by a positive 2. So times 2 here and times 2 here. Whenever you have a variable being multiplied and divided by the same number, they cancel out, oh, there we go. They cancel out to the number 1. Let me go ahead and show that. Oops, I keep moving my little menu there. There we go. You cancel out to number 1, so I have a 1x. And then I have is less than a negative times a positive is a negative, 3 times 2 is 6. So basically, x is anything less than negative 6. You may be wondering why my sign didn't flip. That's because when I was multiplying here, I was multiplying times a positive 2 and not a negative. Only when you multiply or divide by a negative number will you flip the sign. In this case, there was none of that happened, so my sign did not flip. X is any number smaller than negative 6. So if I create my number line to show how it's going to look, I know I'm dealing with negative 6, so I'll put 0 over here. 1, 2, 3, 4, 5, 6, 7. I'll label every other one. There's negative 2, 3, negative 4, 5, there's negative 6 right there. X is any number smaller than negative 6. Smaller than or less than, not equal, which means it's going to be an open circle. And everything is smaller than negative 6 when you go to the left. So there's less than, and this is how my graph should look. Of course, you can put this graph on the line itself, but I like to draw it floating above to make it a little easier for you guys to read. Usually the graph will be right on the number line itself, something like that, and all drawn in. But it doesn't really matter where, as long as you know how to read it. If you have any questions, write them on the side. If not, let's progress right to the next example. So we now have example 4. This one's a word problem, but it's going to follow the same pattern. So I'm going to go ahead and take out all this stuff here. I don't want it to get in the way and distract me before I read my problem. And I recommend you guys do this before you read word problems to cover up any distractions. That way you won't be tainted by what's there and you can just read. So our instructions for number 4 say, write and solve a real-world problem that can be represented by the inequality 0.25x plus 20 is less than or equal to 30. So here's the story they came up with. Addison can spend up to $30 each month. Addison can spend up to $30. That means they can spend exactly 30, which is the equal sign, or they can spend less than 30, which is this symbol right there, for her cell phone. The cell phone company charges $20 for her plan and 25 cents for each text message. How many text messages can Addison send without going over 30 bucks? So basically, we wanted to solve for this little x right here. We want to know if each text message, let me go ahead and write this. We want to know that if each text message costs 25 cents, how many can she send, that's what this is, as well as pay her $20 fee just to have the phone, can she send, that'll be less than or equal to $30. So it's kind of like you're on a real strict budget here. So let's figure out how many text messages could you send if each one only cost a quarter and you had to spend $20 on just keeping your phone and all you have is $30 total. Well, let's go ahead and talk about what we have. Our variable is x. It is being multiplied by 0.25 and it is being added by $20. When we go ahead and write the inverses down, we have divide by 0.25 and subtract 20. These are the two steps we're going to use. We want to always clear up our addition subtraction first, so we'll go ahead and address the minus 20. Okay, so if we have 30 bucks, we know that we have to spend $20 for sure on just the phone bill to keep the phone. So I'll get rid of that 20 bucks to figure out how much money I have left to work with. All this stuff with the x comes right on down. So 25 cents for every text message that I send has to be less than or equal to, well, if I have 30 bucks total and $20 goes every month to my cell phone bill just to keep it activated, then that leaves me $10 left for text messages. So now I'm basically being asked how many quarters will fit into $10. Well, in order to figure that out, I'm going to have to divide both sides by 10. Excuse me, by 0.25. I don't know what I was thinking saying 10. Divide both sides by 0.25 because I already did this step. Now I have to do this step. I'll use the fraction bar or biculum. Divide both sides by 0.25. 25 goes to 25 one whole time. Since I was dividing by a positive number, my symbol will not switch directions. Now, how many quarters are there in $10? Well, if there's 4 quarters in $1, then there's 40 quarters in $10. So basically, Addison can make less than or up to 40 text messages every month. And if you're like me, I probably do that in just a couple of hours a day. I can't imagine trying to do only 40 text messages a month. Good luck, Addison. You may want to consider either getting a better phone plan or maybe getting a better job that pays more, because I don't see how anyone can live nowadays with just 40 text messages a month. Nonetheless, if you have any questions about how this problem is solved or how we solved it ourselves, please write a note on the side for yourself so you can ask in class or whenever you come for tutoring. If you think you have a pretty good grasp, then go ahead and complete the Got It, C, and D, and E here on the bottom. If I were you for part E, maybe come up with a problem that's almost exactly the same as example 4 for this part here. These are all modeled in the examples above, so you shouldn't have too much problem. Good luck, and I will see you guys in another lesson.